Now let's take up the next question, that is question number 13. The question you see here belongs to section of heat and thermodynamics from the chapter kinetic theory of gases. Here, for a given gas at 1 atmospheric pressure, RMS speed of the molecules is 200 meter per second at 127 degrees centigrade. At 2 atmospheric pressure and at 227 degrees centigrade, the RMS speed of the molecules will be. So, in this question, we need the relation and we need the value of the final RMS velocity at this given temperature. So, you are well aware that Vrms is directly proportional to root of the temperature. So, I will say V2 by V1 is equals to under root of T2 by T1, and these temperatures should be put in Kelvin. So the value of this would be 500 Kelvin and value for this would be 400 Kelvin, right? So from here, if you write down it, you will get 500 by 400. On solving, you will get V2 is equals to V1 by 2 into root of 5. So it is 100 root 5 meter per second. Let's see which is the best suited option. So among the 4 given to us, yes, option number 1 would be the right answer to this question. Now let's move on to the next question, that is question number 14. Now the question you see again belongs to section of electromagnetism from the chapter electrostatics. Here a capacitor with capacitance 5 microfarad is charged to 5 microcoulomb. If the plates are pulled apart to reduce the capacitance to 2 microfarad, how much work is done? Simply it is the difference of the potential energy between the final and initial states. So what was the initial potential energy? That would be Q square by twice of C1. What is the final potential energy? That would be Q square by twice of C2. Now let's put down the values. So work done would be equal to Q square by 2, 1 upon C2 minus 1 upon C1. Putting down the values, we have got everything. We will get 3.75 into 10 to the power minus 6 joules. So let's see which is the best suited option here. Among the 4 options given to us, option number 3 is the right answer. Right? Now let's move on to the next question, that is question number 15. The question you see here belongs to section from heat and thermodynamics from the chapter thermodynamics itself. As per the question, following figure shows 2 processes A and B for a gas. If delta QA and delta QB are the amount of heat absorbed by the system in 2 cases, then delta UA and delta UB are the changes in internal energies respectively. Then we have to find that according to the given conditions, which one is the best option. From here, it is quite evident that the initial and the final points are same for both the processes. That means the change of internal energy will be equal, right? So second case, work done in case A will be greater than work done in case B. So obviously the heat, that is delta QA for first process, would be greater than delta QB from the second process. From all the 3 conclusions, option number 1 would be the correct answer to this question. I hope you have understood this one pretty easy. Now let's move on to our next question.